Hello everyone! Welcome to today's STEM class. 3D printed pull-back car. Have you ever played with a car that can run on its own when you pull it back? Today we are going to use a 3D printer to make our very own pull-back car with our own hands. In this lesson we'll learn how 3D printing works, how simple machines are built, how gears turn, and how to add creative colors to our design. Are you ready? Then let's get started together. This is the pullback car we're going to make today. It may look small, but it's made of more than 20 different parts. Each part has its own special job. The wheels help it move forward. The gears pass the power along. And the spring inside is the secret. That makes it pull back and go. When all these parts are put together just right, they form a tiny energy-changing system. When we turn the handle, the spring stores energy. When we let go, the energy is released through the gears, and it pushes the little car forward. Sounds amazing, right? Next we'll find the model in the app and print. These parts ourselves turning creativity from an idea into a car that can actually run. First open the PoloPrint cloud. In the model library, find the pullback car we're making today. After clicking in, you'll see a complete model preview. It includes more than 20 parts such as the car body, car cover, wheels, and gears all need to be printed separately. Let's start by printing the wheels first. Choose a filament like the white PLA. Click Print and the printer starts working. Filament comes out of the nozzle and builds up layer by layer, slowly forming the shape of a wheel. This is the most amazing thing about 3D printing. It doesn't cut material away, and it doesn't use a mold. Instead, it builds things layer by layer, creating something from nothing. Printing one wheel takes about 30 minutes. One part is finished. Next, we need to print the other parts, the gears, the axles, and more. As each new piece is printed, our pullback car slowly comes to life. Now let's start assembling the pullback car. The whole process takes about 5 minutes. Please be patient and carefully observe each step. Step 1. Take out the car body and wheels. They lay like the skeleton of the car, determining the overall structure. Step 2. Next, pass this handle through the middle of the body. Step 3. Then thread the spring through the handle and secure it with the idler gear axle. Step 4. Press the pawl into the pawl gear, then install the pawl gear and the idler gear. Step 5. Turn the handle gently a couple of times to ensure the gears mesh correctly. The core of the pullback mechanism is now fully assembled. Step 6. Install the floating guide for the floating pinion gear on both sides of the body. The longer guide goes on the right body. These guides support the floating drive mechanism. Step 7. Install the floating pinion gear and its alex into the right part. Step 8. Next, assemble the rear alex and its gear and place them into the right body. Step 9. Now it's time to join the left and right bodies. First, insert two spacers onto the axle to fix the gears. Then, align the left and right bodies with the fixing holes and press gently to lock them. Be careful to move lightly to avoid part misalignment. Step 10. Then add the cross member and wheels. Secure the left and right car bodies tightly. Great! After assembly, remember to check if each gear rotates smoothly. If any gear gets stuck, realign it and adjust by rotating gently. All set. Now let's test it out. Turn the handle. Let go. Look, it's running. After assembly, Let's figure out how exactly does this car run. How do these parts work together to achieve energy conversion? When we turn the handle, the spring is tightened, storing potential energy. When released, the spring releases this energy, converting it into kinetic energy. The kinetic energy is transmitted through the gears in sequence. The spring gear drives the idler gear. The idler gear drives the floating gear. And finally, the rear wheel gear. When the rear wheel gear starts to rotate, the wheels turn along with it. As a result, the car moves forward on its own. This demonstrates what we call in science potential energy being converted into kinetic energy. So can you guess what would happen if we replaced the spring or gears with larger ones? Would it be faster or more powerful? This is the most interesting part of scientific experiments, constant trial and exploration. Besides structural design, we can also match the car with exclusive colors and car cover styles. You can choose the classic racing red with black, or try the fresh blue and white combination. You can also use different types of filament, like silk or matte filament, to create different styles. Add your own design stickers and numbers, and you will have your own exclusive racing team. Okay, now let's test it again. Pull the car back. Let go. This is the release of mechanical energy, the perfect combination of science and creativity. Today we've completed a pullback car with 3D printing. We learned about 3D printing processes, mechanical structures, energy conversion, and creative design. In STEM class, we understand science through hands-on practice and discover joy in creativity. 3D printers help create a better life.